Radiation. The problem reads, steam at 125 degrees Celsius flows through a 3-inch scheduled 40 steel pipe with H equal to 7,000 watt per meter Kelvin. The pipe is covered with 1 centimeter of insulation having a thermal conductivity of 0.02 watts per meter Kelvin and an emissivity of 0.87. Find the wall temperature if the surrounding air is at 30 degrees Celsius. Here is a diagram of the tube insulation with its properties. The tube used is a 3-inch schedule 40 steel pipe having these properties. The DSO would be the outer diameter plus times 2 of the thickness, which is 0.1089 meters. And given HI, which is 7,000 watts per meter squared Kelvin. First, we can solve for HR given this equation. But before that, we need to solve for the sexy F from 1 to 2, given this equation. But since the area of the surroundings is much greater than the area of the tube, that would make F from 1 to 2 equal to 1, making the sexy F equal to the emissivity of 1, the emissivity of the insulation, which is 0.87. Given that, we can solve for HR, which is 6.3615 watt per meter squared Kelvin. After solving for HR, we need to find for HC, which is given by the Nusselt's equation, H times D over K. And since this is a vertical tube, we can find in the Perry's handbook this equation for the Nusselt's number. In this equation, we need to find the Rayleigh number and the Prandtl number. To solve for the Rayleigh and the Prandtl number, we need to find the properties of air at TF. Here we assume that the wall temperature is at 60 degrees Celsius or 333 Kelvin. TF would be 60 plus 30. After solving TF, we can find the following properties from the Perry's handbook. And we substitute these to those two equations to find the Rayleigh number and the Prandtl number. After solving for these two, we can substitute them into this equation and find HC, which is equal to 4.7583 watt per meter squared Kelvin. After solving for HR and HC, we can sum them up to find HO, which is 11.1198 watt per meter squared Kelvin. And since this is radiation, we always use UO. We need UO in order to check our wall temperature at steady state. We can solve for UO given this equation, and it will give us 1.3438 watt per meter squared Kelvin. And we can substitute this value in the steady state equation here, cancelling the area, and it would give a wall temperature of 41.48 degrees Celsius.